Good morning, everyone. My name is Grant Foster, and today I'll be giving you a short presentation on vibration in natural gas compressor stations. Quick background on myself. I am currently working in the oil and gas pipeline construction industry and service industry, and I'm also a student at LSU online. Today, the first thing we'll be talking about is the basics of what is a compressor station. Well, compressor stations are a part of the midstream in the natural gas pipeline industry that take gas from the gathering fields or wellheads and compress it to deliver it to the end user, whether that be a refinery or residential heating homes and things of that nature. There's a couple different methods that operators use to compress gas. Most of the new stations that are constructed use turbines to compress the gas, which is a better system, which more costly, but is a more efficient system overall. All of the older stations, which is majority of the stations we see, are engine type reciprocating compressors, which are the main cause of the vibration in these stations. A little bit about the age of compressor stations. The reason that most of the stations we see have the reciprocating type compressors is because the age they were built. They were built right after World War II, which puts them around that 50, 75-year-old mark. And the cost of repairing and modifying these is a lot cheaper and more cost effective for operators rather than converting them to turbine style, which would imply downtime being involved and just makes it a very ineffective from a cost standpoint. There's several things that cause the vibration in these stations, whether that be turbulent flow, mechanical vibration, pressure pulsation, cavitation, or two-phase flow. All these cause vibration, which has several negative effects. These effects being failure of piping, which 10 to 15% of all piping failures come from excessive vibration. It causes wear on supports. The instrumentation has to be specialized instrumentation and have special, say, volume bottles or pulsation bottles to be able to have effective pressure and temperature readings, just to kind of get an isolated reading that isn't in that turbulent flow, which turbulent flow is the main thing that causes this vibration. Now we'll talk about what can be done to mitigate this vibration. Orifice plates can install. These are typically installed on the vertical, on the suction and discharge of compressors, which say you have a 16-inch suction and discharge header. That orifice plate on the vertical will smooth that flow out, which lessens the vibration. You can install new specialized easy line types pipe supports, which have provisions built in that help mitigate the vibration of piping. Increasing wall thickness, just increasing the rigidity of the system, is something that can be done and is done frequently, but can have other negative effects on other parts in the system, because when you increase the rigidity of the pipe, then you start getting wear and tear other places. Reducing number of bends is all about getting that turbulent flow to turn more into a laminar flow. And below grade, what we can do is we can install thrust blocks, which for a lot of these older piping systems that actually has coupled pipe, those thrust blocks can prevent failures in that way. I appreciate everyone taking their time to view this presentation. And just a little tidbit here, this is a old compressor with a new suction and discharge on it, with you can actually see there the orifice plates flanged in there on the vertical.